Hello, can you hear me?
Yes, sir.
Okay. You have any doubts regarding anything? You have to tell some feedback of the course will happen like last week or something. How was your course and how you people feeling that coursework and assignments problems? Whether this is difficult or easy or moderate, or how the Oslo is happening. These things are easy or you want more clarification or something. You can tell, speak, no problem. 1 minute. I'm just come. Yeah, how the course is going on? Any feedback? How was the assignments? Is it good or bad or
Sir,
not?
it's going well, sir.
It's going well. Okay,
Yes,
nice.
yes, sir. Sir, actually, I have some doubt regarding the sign convention, sir. Sometimes I am confusing more in sign convention where we have positive, negative, and that's all.
Okay, okay. Yeah, you
Yes.
may have faced a
In the
different.
in the in the previous last assignment, uh, many questions are wrong regarding sign convention.
Okay, okay,
Magnitude is same, but sign convention is a little bit confusing.
okay. Yeah, okay. I can tell that. Yeah, you may have seen some sign conventions which may use it like Cartesian method and mm, like another methods. But here it's like that way. You may have already seen that
Yes, sir.
in that lecture how the signs are taking.
Yes,
So
sir. It is also given in the assignment in the upper side. Like,
yes,
yeah, you are
yes, 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 yeah. The second
yes,
assignment first, yeah.
yes, sir.
So actually, now I am mainly thinking that I will go through this assignment one and two, through which and along with this one, we can actually see what are the doubts coming there. It is not like we are not just solving that thing. Actually, we can see that what are the information we will get from that two assignment sets. Okay.
Yes, sir. Yes, sir. Okay, sir.
Okay. I think yeah. Let if people are joining, let them join. Now anyway, we can start. We'll start from the assignment one because assignment zero we discussed last time. Yeah, we can see that some model questions can be done because I am recording this meet such that and I will upload this thing such that it will be useful for you people to see in later time also. Let's see. But yeah, it is better to be like yeah, if you are attending live, that will be better such that you can directly tell and I can also understand what are the problems you people are facing and how that can be overcome. Okay, let us see the assignment problems. I am going to share my screen. Can you see the assignment questions?
Yes, sir.
Okay. Now you can see my screen now.
Yes, sir. Yes, sir.
Yeah. In your thing also, this assignment the results are came. Means they are showing the answers now.
Yes, sir.
Okay. Now we can see. Let us start with the first question. Which of the following explained by geometric optics? Okay. Now see. Let us see all the options. You can directly see. Yeah, answer is given there, so you don't worry about the answer. Okay, we can go through the each options. The bending of light due to gravity. Is there any phenomenon like a bending of light due to gravity? The gravity bends light. Anybody know?
No, sir.
So, but there is a
In case of space, the light bends in uh, due to gravity. So there
uh,
is a circular
yeah. In the case
bending.
of if you are talking about general theory of relativity, there is a bending of light due to gravity. It's not like exactly bending of light. Yeah, it's the gravity causes a big curvature in the space time, and the light can bend through that way, and light's motion will be like in a curved path. That actually explained by general theory of relativity. Okay, not like our geometric optics. Geometric optics is a very simple thing. Next thing, the behavior of anti-reflection coating. You know, there are some anti-reflection coatings are there. In the case of what we can say, yeah, the windshield of mm, vehicles as well as our sunglasses everywhere. Now we can see different kind of anti-reflection coating. So, what is the phenomenon behind this one? Anybody can tell? Anybody?
Reflected rays sent back.
Uh,
Uh,
but yeah, if all the lights reflected rays sent back, then it's not an anti-reflection. It's a reflection. So what is the anti-reflection? You can tell any answer, whatever. Yeah, it's a good guess. How the reflected rays we are suppressing. Actually, we don't want the reflection. That's why it's called anti-reflection. How the reflected rays getting suppressed. So it's not anything related with this one. You may have heard about constructive and destructive interferences. This is actually a part of interference is coming in case of a wave only. So actually, in the case of anti-reflection coating, we are using lights reflected from multiple layers of the coating, and we will choose in such a way that one particular reflected light will superimpose with another light and they will form a destructive different interference and they got cancelled. So I already told these are like a dealing with the different kind of waves. So geometric optics is dealing like the particle nature of light. So the behavior of anti-reflection coating can be explained only by wave optics. We cannot explain geometric optics for that. Next, the amount of light traveling in a particular direction. The underlined word is amount of light traveling in a particular direction. Can we tell based on geometric optics how the amount of light depends on what are the parameters? You can tell. While traveling the light from a medium, light can get absorbed, or if the medium contains some particle, it can get scattered. So each things are actually depends on the amount of light traveling in a medium. So when the light is getting absorbed, we cannot explain by geometric optics. Scattering also, sometimes the scattering is actually depends on the wavelength of the light. So we cannot explain the amount of light traveling in a particular direction or in a medium only using with the geometric optics. So if you don't know itself the particular answer, you can just cut out these all three answers. Now you see that the direction of light transmits through a interface. Can we tell based on the geometric optics? Direction of light transmits through an interface. It can be a reflection kind of interface, or it can be a two transparent medium separated by a interface. Can we tell light travels direction of the light? Yes or no? Anybody can tell. Whether I'm not disconnected now. Okay.
Light travels in a straight line.
Yeah. If it's a single medium, light travels in a straight line. So that can be told by
Homogeneous medium.
yeah, yeah. It's the same homogeneous medium. Light is traveling in a straight line path. When it is hitting at an interface, what happens?
It gets reflected or refracted into that
Yeah,
medium.
yeah. It can get reflected in the same medium, or it can get refracted
Refracted.
to the other medium. The same medium is governed by laws of refraction, and the refraction is governed by Snell's law, and both can be explained using geometric optics. So the answer is fourth answer. So the direction of light transmits through an interface can be explained using geometric optics. Okay. 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 You can see the next question. If you have any doubt in between, also you ask her. Okay. Let's go like that way. So when we are completing this assignment, you should know all the things, what all the information that can be extracted from these questions. That is our motto. Okay. Next, second question. Which of the following state is correct or statement considering Fermat's principle? Light always travels from one point to another point in a straight line. Whether it's correct or not. Light always travels from one point to another in a straight line. Whether that is correct or not. That's the question.
No, it is not mentioned whether the medium is homogeneous or not.
It is not at all mentioned whether there is a. It's only said that one point to another point. They are not at all mentioned anything regarding homogeneous medium, or it's if there is an interface between the two points, whether these two points are in the same medium. So you cannot tell like that way. Okay. Next, let's see. We want to let us see. These are the options. Light always travels from one point to another point in a straight line. Let us see. You can see the monitor now. The shared screen you can see now.
Yes, sir.
Okay. So I say I have one point here. I have another point here. And if it is a homogeneous medium, what happens? A light can travel from here to here in a straight line manner. But it is not at all mentioned that whether this medium is a homogeneous or not. So that can happen like that way. There is a interface between these two medium. And what happen if there is an interface? Light can bend also. Okay. And some of here. And the straight line path is like this way. But the light will travel in a path which is a bend. So light always travels from one point to another point in a straight line is actually wrong, because now it's like the path is bent. Okay, so this is not correct. Now light travels along the path of the least time in most practical cases. This is correct or not? This is a correct statement. The Fermat principle itself is saying that light always chooses a path in which it can cover in least time. That is the nature of light in a medium. So that is given by Fermat's principle, and it's always try to choose a path which is covered in the least time. Light travels along the path of least distance. Whether the least time can infer the least distance, whether you have a doubt or something like that way. So the least time says least distance. So you can see this one, the same example which we took. Here is said this is actually the least distance path, but light is want to travel in a path through which the least time. So least time means this is moving in a bend path, but with a least time. So least distance doesn't mean that least time doesn't mean that's a least distance. The distance can be more, even though the time to reach the point is less. Okay. Next, Fermat principle can be used to derive the law of reflection. Can we use Fermat principle to derive the law of reflection? Actually, you can. Even reflection and refraction can be derived using Fermat's principle. Okay, and the same equation you are seeing at the bottom side. The third question. Third question is the principle. This is the way in which you are using deriving the law of reflection using Fermat principle. And if you derive this, if you try to solve this equation, you can see that it can be nicely come. What you will get? You will get a theta 1 is equal to theta 2. So Fermat principle can be used to derive law of reflection also. Okay. For the second option, there are two right answers. They are like light travels along the path of the least time in most practical cases, and Fermat principle can be used to derive the laws of reflection.
Sir, in this question,
Mhm.
light travel along the path of least time in most practical cases. It
Yeah.
is not stating always. So,
Now,
in which case it is not possible or it is not invalid.
in that case, actually, Madam was saying about one example in which the gravitational bending is there. Na? In that case, there can be like that way. The Fermat principle always saying that light travels along the path of it is like the path length can be a minima. So it can happen like that way. It can be a maxima also. So in the case of gravitational bending of the light or something, like that madam was mentioning in the first lecture or second lecture, says that in
Okay.
that case
It
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 can,
is
yeah,
okay.
can travel in a, that's why that's given, say the most of the our lifetime cases that is not at all come, so always it is coming in our normal life, just like a least time only.
Okay. Okay. Thank you, sir.
Okay. Now see the third question. Consider the light ray shown in this diagram. You people are already gone through this question now, so I don't need to read the questions. So you see which operation actually proves the laws of reflection. See, dt by dx is equal to 0, integral t dx is equal to 0, dl by dx is equal to 0, dl by dx equal to, what is that one? So what is the laws of reflection is saying angle of incidence is equal to angle of reflection. How we are deriving that one? We are deriving using the Fermat's principle. And what Fermat's principle is says, the time travels from one position to another position, and here actually we are considering the reflection, and through with this path, and light chooses a path such that the time is minimum. And now see which equation says like that way. If time is minimum, if you already see that one, if particular, if you want to minimize a function, we have to, if a function, you people will be knowing now, I can say that. Just to think that it's a mathematical function. So y is equal to f of x. I'm saying the function is having a shape like this way. And I want to find these portions. And this is x, this is y. And if I want to find a point of minima or a point of maxima, what is the condition? What will be the value here? The point of minima or point of maxima says that the derivative of the function with respect to the variable will be 0. So in the case of the function, here we get dy by dx equal to 0. Here you will get dy by dx equal to 0. So similar way, we are actually minimizing the time. So we are minimizing the time with respect to a variable. This is the x distance. So what will be the option? The time should be get minimized. So condition is like that way. dt by dx should be equal to 0. The thing is that it takes a path through which the time is minimized. So the correct option is A, showing dt by dx equal to 0. Okay, any doubt? Hopefully no doubt. Now, of the following is or are not correct for an optical system. Any optical system has a pair of conjugate points, whether it's correct or not. People are hearing now, since because when I am sharing my screen, I cannot see you people. So it will be nice that if you people can give some feedback through voice. Okay. Any optical system, we can consider the pair of conjugate points. It can be anywhere. If you're putting an object point at somewhere, if you are getting an image point at another point, we can say that they are actually conjugate points. Sometimes the conjugate can be at infinity also. So don't worry. Sometimes you will see that okay, we are not getting a point at a particular finite distance. That can be like a infinity also. You can see that in the case of a lens, in which if you have placed a object at its focus, image will be formed at infinity. Similar way, if the object is at infinity, you will get the image at a focus. So it can happen like that way. One of the or two of the conjugate point can be at infinity also. So you don't worry about the thing. If an optical system, then it can have a pair of conjugate points. That's actually correct answer. But you don't want the correct answer, you want incorrect answer. For an imaging system, set of rays reflected from a point on an object is focused using an optical system to obtain the same point on the image. That's correct or wrong? Now you can see that that's correct or wrong. But any clarity you required for that one? That you may have already knowing. So if I want a now you want to take a image of a particular thing. So I have a leaf. I have a leaf, and I am taking a picture of a leaf using a camera. What it should get in the picture? Actually, I am taking the picture of a leaf. Now I see I have a particular point here, and I want and the lights are coming this point to this camera, and all this light should be focused in a particular image point, and some lights are coming from this point. And this thing also should be pointed in some particular point such that my image should be of the leaf only, the same leaf. The whole point from this point should reach the similar point in the image itself. Similar way, this all points from this point should reach somewhere here. Otherwise, that your image will not be proper to watch. It will be something else. So, if every point on the object plane, object should be there will be a corresponding point in the image. If the optical system is doing that thing only, then we can say that our optical system is a good imaging system. If all the light coming from this point should be focused at this point. Similarly, all the points coming from this point should be focused at this point, such that we will get a proper image. So it should be that should be a correct answer. Next, amount of light that can be collected by an optical system is limited by diffraction. So correct or not? That also you can see. It's actually amount of light that can be collected by an optical system is limited by diffraction. What will happen? You already see that light can bend, due to the refraction, light can bend at the edge of an aperture. True? You know or not? Some feedback will be useful. The light can bend at the edge of the points or something.
Yes.
Yeah. And
Lambda by 2.
yeah. So if the wavelength of the light is comparable with that slit width or something, what happens? Light can bend. So you cannot go on using all the aperture and say that all the light will reach there, because the light has a wave nature also. So what happens if you are passing through your light through a very small aperture or something, you can see that there will be some diffraction will come, and light will go in a geometrical shadow region. You may have knowing this one. Sorry. You know the diffraction of light, and just say, just think that you can do this experiment also. You take a cardboard paper and make a hole. Okay, and let us have a light bulb or something here. And this bulb is lit. What you will see here, if you put a cardboard paper with a small hole, not small hole, something considerably big hole, you will see on the back side of this thing, you will see whole shadow, and there will be a circular portion which having a light. Correct? What happens here? Here actually light is coming here and falling here. This thing also, it is coming here and falling here. Okay, this is like a normal case. But you say, think that you are decreasing the size of the hole, very small, and it's like a small pinhole kind of thing. You will feel that okay, light will also go and fall in a small region. But actually what will happen, if you are going like that way, you can see that there will be a middle portion which is bright, and there will be some ring kind of thing. First order ring, second order ring, zeroth order ring, zeroth order will be a spot. Like that you will see. Even though this hole is so small, you will see light is reaching at a, not only this whole place where there should not be any light. It can reach here also, it can reach here also. And this is caused by diffraction. And this bending can actually really change the amount of light reaching in the screen. So diffraction can cause a lot of change amount in the light. Okay. Now see, resolution of an imaging system is not limited by wavelength of the light used. That's correct or not? I said that not limited by. Now we already see that one. Because the amount of light can be collected by an optical system is limited by diffraction. Diffraction can change the amount of light reaching that optical system. So if that is correct, now you see the resolution of an imaging system is not limited by wavelength, they are saying. Diffraction will be prominent if the wavelength of the light is comparable with the size of the slit. Now you can see here, this will be very highly visible if that small size of the aperture is comparable with the wavelength of the light. So wavelength is actually affecting the resolution of the image. Okay, so they are saying that it is not, so that is the wrong answer. So if you choose that answer, then your answer is right answer. Okay, select all the options that are conditions necessary to see a light beam as it travels through a medium. Select all the options that are conditions necessary to see a light beam. You want to see a light beam when it is travels through a medium. Now you already see the answers. Let's see. The wavelength of the light should be in the part of the spectrum which our eye can perceive. Is that correct or not? We are seeing that that's already the answer. You want to see light is passing through this medium. You want to see the path of the light. Light has to pass. You have to see that it is passing through the medium. What are the condition? Anyway, if you want to see that one, it should give some seeing effect. So the light wavelength should be perspective to our eyes. What is the wavelength range which our eye can see? That is called visible.
380 to 740 nanometer.
Yeah. So roughly we can say some 400 to 700 we can say. Okay. So there will be like, yeah, from violet to red we can see. If it's beyond the red, means increase in the wavelength of the red, it is called infrared, we cannot see. If it is below violet, that is called ultraviolet. Both of them we cannot see. We can only see the visible region which is coming around 380 to 720 or something, yeah. Or we can say roughly say 400 to 700 nanometer range only. So only we can see that light. So not to see that one, only that particular wavelength range should be there. That's decided. Now, second, even though can we see that one? Can we see the path of the light if the light is passing through a medium? Not to see the path of light when the light is passing through a medium, some light should reach our eyes also. Correct? If light is passing through one direction to another direction in a medium, we cannot see the light until the light should reach in our eyes. So there should be some particle that scatters the light in the medium. Then only we will see the path of the light. Okay. So the answer is, have two answer. The two answers are, a wavelength of the light should be in the part of the spectrum which our eye can perceive. That's, yeah, it should be in violet to red. A medium without any scattering particle. If the medium is a very clear medium without any scattering particle, you cannot see whether the light is passing through there or not. A medium which contains scattering particle, that we explain now. Yeah, that's correct. A medium with varying refractive index. Whether whatever this one, why can't this is true or not? Can't it be true? A medium with a varying refractive index. What is the problem with that one? Varying in refractive index, let's just think that this is the interface of the two medium. If the light is passing one medium to another medium, it can bend. Sometimes what happens at this interface, some light can reflect and reach your eye also. Okay, but if you are reflecting the and reaching your eye, you will only see that some light is coming at this interface. Even though you can see some light is coming at some particular point, but you cannot see that original path of the light, even though there is some reflection is happening at an interface. So not to see the exact path of the light, you want to, some scattering particle should be inside the medium. Okay. In the case of varying refractive index or varying interfaces, you can see some light is reflecting. You can see that there is some illumination is there at particular point. Only you will see like that. You cannot see the path of the light. Only at a particular point you will see some light. That one. You cannot see path. So the answers are, a wavelength of the light should be in the part of spectrum and medium which contains scattering particle. I see unknown liquid taken in a glass vessel. A laser pointer is illuminated from the top to liquid bottom with an angle of 45 degree. It is found that the angle of refraction inside is 32.12 degree. Find the liquid. Which is the liquid? What are the things? Anybody? Everybody got this answer in the assignment set? Whether everybody made the answer correct?
Water.
Got it. Okay. How we will find out that answer?
Uh, Snell's law.
Yeah.
N1 sine theta is equal to N2 sine theta.
Okay. So we will use the Snell's law. What is the Snell's law saying? N1
Sine theta 1 is equal to
okay.
N2 sine theta. Theta
Theta
2.
2. Now we have an interface from which
And sine theta 2.
oh sorry. We have one interface. They are saying that theta 1 is equal to how much? 45 degree. Theta 2 is equal to 37.12 degree or something.
32.12.
32.12. Okay, thank you. N1 is what?
1.
1. N2, actually we don't know. So substitute here 1 into sine 45 degrees equal to N2 into sine 32.12 degree. What you will get? N2 is equal to sine 45 degree divided by sine 32.12 degree. Sine 45 is 1 by root 2 or 0.707 something divided by sine 32.12 degree. How much is that one? Moment. Sine 32.12 degree will come out as
0.53.
okay. Yeah,
0.53.
0.53. It will come like a 1.8. Come like 1.33.
0.33.
So 1.33 is the refractive
Water.
index of
Water.
water. Okay. So we'll get a. So the answer is given like a water having refractive index of 1.33. Okay. So any doubt regarding this one? Now the next question. A helium neon laser emits a red light wavelength. Yeah, these are the things we can go through like that. Hope you people are already gone through this question. Now let us see what are the important points. There are three interfaces. First interface is first medium is air having a refractive index 1. Second medium is oil having refractive index of 1.47 and having a thickness of 1 millimeter, and third medium is a glass having a thickness of 5 millimeter with a refractive index 1.5. Okay, and these are entering in a normal manner. That means the angle of incidence is 90 degree. Now we can see the question. The optical path length associated with the beam traveling from A to B. So we want the optical path difference. What is the optical path difference? What is the equation of optical path difference? Optical path length is equal to the product of refractive index and the geometric distance. Okay, this is the optical path length. Now see what is the total optical path length of in our case. Now we have a laser traveling from, there's a one air, then there is a oil, and there's a glass. And the laser light is traveling from air to oil, then it is traveling to the glass and coming outside. This point is A and this point is B. And this is distance is given as a 1 millimeter, 3 millimeter. Thickness is 1 millimeter and glass thickness is 5 millimeter. This is a 1 mm. This is a 5 mm. This 1 mm and 5 mm is a geometrical distance. And the refractive index is n is equal to 1.47, and one I can say n2 is equal to 1.5. So what is optical path length between air and this air oil interface to oil glass interface? What is optical path difference? That will be product of 1.4 refractive index and geometrical distance. So it will be here 1.47 into 1 millimeter. Here second medium 1.5 into 5 millimeter. So what is the total optical path difference from here to here? You have to sum this one. So you'll get a 1.4. Yeah, somebody has doubt?
So 8.97.
Okay, so it will come like 8.97, and if you write, there's a, they have given some buffer zone like 8.9 to 9.1. If you given, your answer will be correct. Okay, now you see the time taken by the beam to travel from A to B. Now we got the path length. What is actually meaning by optical path length? What is mean by the 8.97 millimeter as my path length? What is the meaning? It is the equivalent length. Now we see that only light is traveled from A to B, and actually it is traveled in a geometric length of 1 millimeter as well as a 5 millimeter. So 1 plus 6 millimeter only this light is traveled from A to B. If you are measuring with a scale, you can see that A to B it is traveled like 6 millimeter. But it is actually light is traveling in a medium at a velocity much slower. So you want an equivalent distance traveling in vacuum or air. So that equivalent length is called the optical path length. So the optical path length from A to B means if the light is traveling from this through this two medium is equivalent that light is traveling at a higher distance of 8.97 millimeter in air. So light is traveling in 6 mm in this medium is equivalent as light is traveling in 8.97 mm in air. So now these are like equivalent. So now I want the time to travel. So we already know that equivalent distance as 8.97 mm. So our time will be, time is equal to distance by velocity. It is like 8.97 mm. 10 raised to minus 3 divided by velocity. What is the velocity? Velocity of light in vacuum. 3 into 10 raised to minus 8 meter per second. You will get the answer as 2.99 into 10 raised to minus 11 second. You get this answer. Any doubt in this one? This you can do in another way also. Same thing you can do in a difficult manner. The same thing you can do in a difficult manner. Actually, what you can do, you can separate out these two paths. You can see that 1 mm here. This is 5 mm here. The refractive index of 1.47 here. 1.5 here. Now first calculate the time at which it is traveling in this interface. So 1 mm, 1 into 10 raised to minus 3 divided by velocity of light in that medium. That will be like a c divided by n, means the refractive index. So the velocity will be less. So the n will go up. So it will be like a 1.47 divided by 3 into 10 raised to 8 into 1 mm. Similar way, in the second medium also it will be like a 1.5 into 5 mm divided by 3 into 10 raised to 8. Then you have to add this T1 and T2. You can see that that is actually thing you are doing here also. So it will come out as a 1.47 into 1 plus 1.5 into 5. This is in millimeter, 10 raised to minus 3 divided by 3 into 10 raised to 8. This is already you calculated 1.47 into 1 plus 1.5 into 5. That is your 2.99. Sorry, 8.97. So it will be like 8.97 into 10 raised to minus 3 divided by 3 into 10 raised to 8. It will also give the same answer of 2.99 into 10 raised to minus 11 second. So you can see that you can choose which way you have to do. The both ways are correct, but this is a little bit tedious with more steps and other thing. You have to think more and do this one. But both ways are correct. You will get the same answer. 2.99 into 10 raised to minus 11 second. Okay? Any doubt? Now let us move to the next question. So we got the path length, we got the time. Now we have to see the what is the phase acquired by the beam while it travels from A to B, and it should be given in radian. Now provide the answer doing a modulo division with the 2 pi. Somebody asked the last time how to do this modulo division of 2 pi. Anybody having that doubt now? Already know how to do this modulo division of 2 pi. Anybody stuck because of this modulo division of 2 pi? And before that one, you have to see the how to connect this face this separation and the path length. Okay, somebody having doubt can ask. No problem.
Sir, please tell.
Okay, first we have to see, we already understood there is a path length, and now we want to get a phase difference. So how to connect this phase difference and path length? So we can say that phase difference is equal to 2 pi by lambda into path length. Okay, this is the phase difference. Phase difference phi we can say as 2 pi by lambda into path length. Now you see, you know 2 pi is a constant by lambda. What is the lambda? Lambda is a wavelength of the light. What is the wavelength of the light? We already mentioned. Say helium neon laser, which is containing a wavelength of 632.880. Correct? Yeah, 632.8 nanometer. So into 10 raised to minus 9. Everything I am doing in SI unit. Into what is the path length? Path length is 8.97 millimeter. So 8.97 into 10 raised to minus 3. What is the value? You people may have already done that. You forgot. The value will be come as 89064.74748. Okay. Anybody got this answer? Hello? Anybody got this answer? Or you got someone else answer? It will come like this way. This is the total phase difference. People are hearing now? Hello?
Yes, sir.
Okay. So what to do next? Now you want a 2 pi modulo. So divide this one with a 2 pi. 89064.74748 divide with the 2 pi. What you will get? 2 pi means 2 into what's the value of pi? Pi is 3.14, that thing. So if you divided that one, you will get a 14175.09. Okay, but we will take only the whole integer value of this portion. So 14175 will take. Now we will see that how we can represent this whole phase difference after taking 14175 into 2 pi portion. This is the original answer. So we had to do so the total phase difference is 89064.74748. We had to subtract this 14175 into 2 pi, and the answer will come out 0.5957 radian. Got it? Two people got this answer? Any doubt for this one? So if you write that answer here, where is the answer? Yeah, 0.5 to 0.7 they are giving. So it's like a 0.5957, it's around 0.6. That is the original answer. And yeah, if you write from 0.5 to 0.7, they will give correct mark. Anybody having doubt for this question?
Sir,
Yeah.
so could we do this like when the light travels from rare to denser medium, it is a change of phase change pi,
Hmm.
and then sir there is a oil, then rare to denser pi phase change, and then from oil to glass.
Hmm.
So then there is a phase change of pi.
Yeah.
After coming out from the glass, from glass to air,
Hmm.
there is no phase change because denser to rare medium there is no phase change. So there is a phase change of 2 pi, right?
That is actually how we will say that phase change is coming from only because of that reflection.
Yeah, yes, sir.
This is actually the phase change, total phase change will come. Now you can see that this is passing through a medium,
Yes, sir.
and through the medium actually what is happening here, yeah, now you can see that, now you can see that the light may be entering like a beam, and you can see that there is a particular phase here, and then also there will be some phase change happening here, this air water interface. And you are saying about a reflection and refraction phase change is like only with respect to this point, what is the phase change happening here, means just after here, one point to one point, this is the phase change because of the reflection and refraction. Now we are not considering about not that phase change. After this one, actually light is traveling like a wave, moving like this way, and the point of interference can be somewhere here, that portion may be here, or, and if it's moving some, there will be some phase change here, and it is moving like here, it may be reaching something like here. So there is a phase change, and this phase is not like this phase, and this phase is not like this phase. So because of this travel, actually there is a change in the phase. Whatever you are saying about this pi phase change and 2 pi phase change is only applicable when one medium to another medium, how you are traveling. And this actually with respect to just like when it is entering here to the other. It is not like because of the travel phase change. So that phase difference is actually you are saying about the phase from here next to the other phase. It is not at all considering the phase change which is causes because of this travel of this one. But actually there is a big phase change which is coming because of your path length difference. So that's a total phase change. That's the one which we are considering now. It is not like a, just one phase change. And you can say that it will only like the integral multiple of pi or 2 pi if this distance is exactly n multiple of lambda, and this thing also should be exactly some integer multiple of lambda. Otherwise you cannot get a integer phase change like a pi or 2 pi. This that phase difference is only because of it is traveling from one medium to another medium. Okay, this is actually the total phase acquired throughout because of this path length travel. Okay,
Okay, sir. Got it.
and 2 pi, and 2, yeah, tell.
Sir, whenever in the experiment we like we do glass experiment, we see that there is only a phase shift. But in this, we are seeing there is a change in the values also. Why is it happening?
Means I didn't get it. What is actually you are taking?
Pardon?
No, what are the what experiment you are telling about?
Sir, glass experiment, glass slit experiment.
What you are taking?
Sir, we used to like get the parallel refracted lines. So there was a phase shift, like there was a delta change, but there was no change in the values. Here we are getting the change in the value due to oil thickness.
No, no, no. You are saying about this like airbags kind of experiment or something.
Sir, glass experiment.
Glass air experiment, you are getting a
Yes.
particular fringe you are getting.
What type of fringe?
Fringe means
Uh,
you are getting like lines.
yes.
How you are getting the lines?
Sir, in that we didn't get any line. We used to project a laser beam and then see that there is a shift in the uh, uh, parallel, that we get a parallel lines, parallel refracted lines.
Okay.
If we used to tilt it, then we get the reflected back line.
Hmm.
But over here we are getting some phase difference values.
There also actually phase difference values are there. You are seeing now. You are seeing parallel lines in between.
Yes.
Yeah, that parallel lines or dark lines or bright lines are coming at that particular point where this your phase shift is a 2 pi or pi.
Yes.
In between also points are there. They're also having finite phase differences, but that points are not like exactly 2 pi. What happens in the case of the phase difference is 2 pi. It will be like a constructive interference. You will get a bright spot. In the case
Okay.
of dark,
Mm.
means what happens there?
Destructive.
Destructive interference. Only that point you can clearly identify as a bright spot as well as dark spot there, and that thing is actually that particular phase difference corresponding to pi or 2 pi.
Yes.
Okay. Yeah.
Any value between that
Yeah,
will
yeah,
not have a significant uh, impingement on the
yeah.
line.
Actually, you will have a significant variation if you are measuring that one through using a photodiode or something. You will get a sinusoidal kind of curve there. You can see that intensity is increasing, decreasing, and becoming zero and becoming maximum. So in between also actually you are having a finite phase difference. You are having a gradient of phase difference, but only at a particular point when your phase difference is like 2 pi or pi, you will get a sharp bands. That only is there. All other portions you are having phase differences there. There are also finite phase difference. But here actually we are calculating how much phase difference is happening there. But since yeah, you can see that this phase difference is like around the 0.9597 radian. So
Yes.
if this is coming like around the 2 pi radian, and if you could interfere this wavelength together, and it is coming like 2 pi radian, you will get a bright wave there, or you could get a path difference is something like that way, such that it is a make a destructive interference, you will get a
Or constructive.
yeah dark region also. So in
Okay.
that experiment, you are seeing you are only looking at points, or you are only considering the points which are giving a particular phase difference. That's why it's coming like that.
Okay, sir.
Okay. So actually phase difference is coming in between also, but we are not, or that is not easy to measure. You cannot exactly say this is the intensity at this point, but you can directly say that this is the dark region. You can easily measure, and you can say that that's the point exactly the destructive interference happening. But you cannot see the all the intermediate intensities. You cannot measure. That will not be easy to perceive also.
For that we use a photodiode.
Yeah, photodiode also you can use, and then you can see that there is a gradual variation in the intensity. But it is
Okay.
easier to count the fringes and doing the calculation if you know that different. These are like we can say that's a 2 pi difference is there in between these spaces. They are making this lines. That is easier to do experiments rather than measuring the particular values.
Okay, sir.
Okay. Yeah. If the incident angle is theta t, theta I is the air oil interface is 50 degree, then the angle of refraction at the glass air interface on the other side of the block is in how much degree? That's a degree. You tell. You can do it's an easy manner as well as a difficult manner. Okay. Now first you can do the easiest thing. So how many interfaces you are having? You are having an air they are saying that it is coming at an angle of 50 degree. So what happens? It will bend. Then there is another interface, next interface. It will again bend. Then there is another interface. What happened? It will go. Now they are saying that this is given as 50 degree. What will be this angle? Okay, theta. Okay. So how will find out this one? We know this refractive index of this medium is 1. This is N1, N2 is 1.47. This is N3. This is 1.5. Let it N4. This is again 1. Okay. Okay. Now we can say that for this interface, what will be like? N1 sine theta 1 is equal to N2 sine theta 2. Okay. What is this theta 2? Here. This is theta 2. Correct? I am not going to calculate now. Now we see what is this angle here. If this is theta 2, this angle of incidence should be, that also should be theta 2 now.
Yes, sir.
So for this interface, what will happen? N2 sine theta 2 is equal to N3 sine theta 3. Okay. This is theta 2. This angle is theta 3. Okay. Then this is theta 3. This is also going to be theta 3.
Theta 3.
So for this interface, what happens? N3 sine theta 3 is equal to N4 sine theta 4. Now we see that this N2 sine theta 2 is the same N2 sine theta 2 here now. So with these 4 equations, what I can write?
N1 sin theta 1 is equals to N4 sin theta 4.
Yeah, N1 sine theta 1 is equal to N2 sine theta 2 equal to N3 sine theta 3 equal to N4 sine theta 4. Now see that you don't want, you only want what? Theta 4. And so you can write that N1 sine theta 1 is equal to N4 sine theta 4. Implies what is N1? 1 sine theta 1 sine 50 degree equal to N4. That also 1 sine theta 4. We got like a 1 into sine 50 degree is equal to 1 into sine theta 4. So what is the value of theta 4?
Sir, same 50 degree.
That will be 50 degree only. So your answer will be 50 degree. Otherwise, if you try to find out the whole angle here, then it will come like always it will come like a similar way, but it will take so much time to solve. Why this is coming exactly like this is 50 degree and this is also 50 degree?
Because our refractive index is same, no?
But here you can see that refractive index are changing.
Yes, sir.
This is only happens because of these surfaces are parallel. That's why you got the angle of refraction at that intermediate is same as the angle of incidence at the same from that interface to another interface. So because of this theta 2 of the refraction angle is same as the theta 2 of this incident angle in the other interface, only because of theta 2s are matching, and the matching of the theta 2 caused by this surfaces are parallel. Okay, only because of that one this equation became very easy. Okay, so yeah, but yeah, this is a very simple calculation. You don't need to do all the calculation to find out different angles. You can directly go for equation It will come like n1 sin theta 1 is n4 sin theta 4, and you will get a 50 degree as your answer. So yeah, so typical range 49 to 51. If you give any answer between that one, your answer they take it as a correct answer. Okay, now we'll see. Any doubt regarding these assignments? Any doubt regarding these assignment questions?
No, sir.
Okay, now let us go check assignment 2. Okay, now let us see. Hope you people are already know the sign conventions and other things. If you have doubt in between, we can solve that one. Okay, I'll see. You know all the lens equations and other thing. I think whether they may have already given here also. Yeah, that's a toy car is placed 50 centimeter in front of a thin negative lens. An image is formed 25 centimeter in front of the lens. The focal length of the lens is dash centimeter. Okay, 25 centimeter in front of the lens. The focal length of the lens is okay 50 and 25. Let's see. So we have a lens system. They already said that it's a thin negative lens. Negative lens means it's a concave lens, and an object is placed 50 centimeter in front of the lens. And an image is formed at 25 centimeter. We don't know whether that image is inverted or erected. Only they are saying that image is formed at 25 centimeter in front of the lens. But here itself we can infer one thing. What is the thing? The image should be erected or inverted. This they given as 50 centimeter, and this they given as 25 centimeter. This image should be erected image or inverted image. Any idea? This is what kind of lens? They already give negative lens. Negative lens means a concave lens. Concave lens will produce image always any idea? Any idea? Oh, you people are not seeing my face. Okay. Any idea? Concave lens will produce what kind of image? It will produce only real image. Okay, it will produce only real image. So sorry, it will produce only virtual image, and it is always it will be in front of the lens, and it will be always erected. Concave lens produce only virtual image, and it will be erected image, that means it will not invert the image, and it will be always in the same direction of that was the object. That is just we will get the information when we are saying that it is a negative lens. Now we see. Now we can solve that question. We want the focal length of the lens. Now we have the equation. Lens equation 1 by u plus 1 by v is equal to 1 by f. What is u? U is a, since we are saying that object is always at the left. If the object is left, we have to take u as a, yeah. Can ask.
Object distance.
Yeah, object distance. If the object is at left side of the lens, you will be positive. So you will be 50 centimeter. V. What is V? If the image is formed right side of the lens, we will take V as a positive. But here they tell that image is formed left side of the lens. So V will be negative minus 25 centimeter. So substitute here 1 by 50 plus 1 by minus 25 is equal to 1 by f is equal to minus 25 plus 50 divided by 50 into minus 25 will be like 25 divided by 50 into minus 25, and you want f will be equal to minus 50 into 25 divided by 25. 25 and 25 will go, and so will be minus 50. Okay. So your answer is minus 50. Any doubt? Any doubt? Hopefully no. Now,
Sir, once show our calculation again.
okay. See, only the thing is that you have to take a proper sign. The thing is that if the object is at the left side of the lens, we have to take u as positive. And the image is at the right side of the lens, you have to take it as positive. But they given that it is forming at the same side. So you have to take v is as negative.
Okay, sir.
Okay. Now let us move to next question. .5 meter tall person is standing at a distance of 2 meter in front of a camera. The camera uses a converging lens of focal length 0.06 meter. Okay, 2 meter, 0.06 meter. The distance between lens and film is. So the question is, there is a one person is standing. Person's height is 1.5 meter, and he is standing 2 meter in front of a camera. That is the camera be a lens. And I want what is the distance between the camera and its film, where that image is found. Here the image is found. I don't know this place, but I know the focal length of the camera is 0.06 meter. Correct? Hopefully correct. Yes. Now see, I want this distance. So I don't know V. Now I know this is lens. So object is at left side of the lens. So U is equal to 2 meter. Focal length of the lens. This is a camera, so it's a converging lens. So focal length will be 0.06 and that will be positive. V, I don't know. So I know the equation 1 by u plus 1 by v is equal to 1 by f implies 1 by 2 plus 1 by v is equal to 1 by 0.06 or 1 by v is equal to 1 by 0.06 minus 1 by 2 will be equal to 2 minus 0.06 divided by 2 into 0.06 implies v will equal to 2 into 0.06. How much? 2 into 0.06 divided by 1.94 will come at 0.0618. This is in meter. So it will be sorry. So it will be as it will come as a V is equal to 61.8 centimeter. Sorry, 6.19 centimeter. 6.18 centimeter. Okay. Okay, na? Any doubt? Yeah. Well,
No, sir. No, sir.
now we will move for the another question. The height of the image is how much centimeter I want. Height of the image is how much centimeter. Now for that one, we want to see what is the magnification of the camera. Magnification is equal to, you can say that height of the image divided by height of the object, or it will come as minus v by q. So we know that minus v is equal to, we already say 6.18 centimeter, but u, okay, so it will be like a 0.61 point, sorry, point minus 0.0618 meter divided by 2. Okay, and that will come around 0.0309 is the magnification. So I want the image height. So image height is equal to magnification into object height at 0. So it will be equal to 0.0309 into 1.5. So there's a negative sign here. It's negative. So it will come as minus 4. You will get the answer as minus 0.0463. You will get. So this is meter, because this is meter. So the answer will be 4.63 meter minus. What is the minus sign implies? Minus sign implies that that image will be inverted. Okay. So if you write the answer, you have, yeah, it's also optional question. So minus 4.63 directly like given. So the answer is minus 4.63. Okay. Any doubt for that question? Okay. Now the next question. Can we go to the next question? Anybody have any doubt? for this question? You can
No,
directly.
sir. No, sir.
Now see the another question. A far-sighted person has a near point at 100 centimeter. What is meant by far-sighted person? What is meant by far-sighted person? You know, usually for a normal eye, a person having a healthy eye, we say that for it is easier to read, that is called our normal near point, will be about 25 centimeter. That is the distance which we properly putting our books and reading. So almost like 25 centimeter, we can read everything in a relaxed mode of eye. If our eye is a healthy eye, it's not like an exact value, but it's like a around. Yeah. Some people cannot see. There are some defects in the eyes. That's called a far-sighted eye as well as near-sighted eye. And we will call the myopia and hypermetropia in scientific terms. Or short sight, long sight. The short sight is called myopia and long sight is called hypermetropia. Okay, the same thing. The long sight is called this far-sighted person. Short sight is called this near-sighted, we can say. So far-sighted person means he cannot see properly the objects which is very near to his eye. It will be blurred, but he can see all the things which is very far away. That he can clearly see. But when the distance is beyond some near to eyes, beyond some particular point, for him it will be very him or her it will be very difficult for see. Similar case in the case of a short-sighted person. The short-sighted person can see objects clearly when these things are very near to our eye. Very near means not very near. Yeah, near to the eye. He cannot see the things which is in the at a very long distance. That will be blurred. So our eyes usually have a capacity to see the distance which is near our eyes as well as the far. But these people, these having some defects on the eyes, having the problem like that, if you can see clearly things which is near to eye and the long distance things are difficult or it's a blurred image, then that is called short-sighted person or myopic person. Or in the case of another person, like he can see this object such a far away things, but it is difficult for him to see or her to see the nearby things. They are called far-sighted person or a hypermetropic person before. Now these defects can be corrected using particular kind of lens. Okay, and we have to see, you can see that people will use in, if you went to some ophthalmic hospital or something, they said that they will change different lenses and they will find out, okay, this lens is useful for you, and they will prescribe a particular kind of glass having a particular power. So similar thing which we are going to do now, we are going to help a person who does not can see. Now see what is happening. A far-sighted person has a near point at 100 centimeter, representing a eye as a simple lens located 2 centimeter from the retina. What is the strength of the lens? He must be able to read a newspaper comfortably at 40 centimeter. Okay. A far-sighted person has a point at 100 centimeter. Now see what is the question says. Now I am only representing the eye of that particular person. The poor person has an eye, saying it has a lens, and it has an eyeball. Okay, and they are saying that the far-sighted person has a near point of 100 centimeter, so he can clearly see only objects which is at a distance 100 centimeter or far. He cannot see anything which is coming beyond 100 centimeter. Okay, this is the problem which his eyes is facing. What is happening here? Actually, at 100 centimeter distance, the light is coming from here. His eye can focus at the retina. This will be, he will be seeing, and the eye we represent it as a 2 centimeter distance. This thing we are saying that's 2 centimeter. Okay, and this distance is 100 centimeter. What happens if anything we kept it in between 100 centimeter? This is something I kept at 50 centimeter. It will go.
He can't.
It will go here, but what happens? It will not be focused fully here. It will get focused at some backside of his eye only. Since here retina has a blurred image, he cannot see this properly. This is the problem. Now you understand, no? So this is the problem. So now let us see with this information what are the things we can obtain. With this information we can obtain if his eye has a lens having a focus length Fe. I'm saying now I can, with this information, 100 centimeter thing can be focused properly. So I can say that we have lens equation 1 by u plus 1 by v is equal to 1 by f. Substitute this one, 1 by 100 plus 1 by 2 is equal to 1 by Fe. Fe is his eye lens. Okay, this I am taking it as equation 1. We can solve this equation and find out the Fe, and using this one we can do the calculation, but I am going to do in a much more simpler manner. Okay, this is the first equation. Based on his condition of his eye, we got this equation 1. Now what he want to see an object at 40 centimeter. Okay, he can only see an object at 100 centimeter. Now he want to see an object at 40 centimeter. That is his wish. So you want to see an object at 40 centimeter. So this is 40 centimeter. So in normal case, he cannot see that one. What we will do, we will help him by putting a lens here. If it's a hypermetropic person, that will be a convex lens here, such that it will help him to get this 40 centimeter thing till correctly focus to retina. Okay, without a lens he can read this 100 centimeter thing, but if it's a 40 centimeter thing, he has to put a lens, then he can see the things properly. Okay, so if the 40 centimeter, then with the lens he can see properly. So in that case, what is the condition? That is the thing we try to derive. Now see, this is 40 centimeter. So here also we will put the same equation. This is the lens having a focal length of FL. So this is 1 by 40. So 1 by u is a 40 plus 1 by v. V is actually same distance from lens to his eye. 1 by 2 is equal to 1 by f. Now 1 by f is what? The combined effect of this lens as well as his eye lens. So it will be 1 by fl, where the fl is the focal length of my lens, plus 1 by fe, where the fe is the focal length of his eye. That I will write it as question number 2. Okay, any doubt? Now do one thing. Now it's a easier thing. Subtract 2 minus 1. What you get? Common 1.1/2, 1/2 is here. That will get subtracted and that will get cancelled. Fe is there, Fe is here. That also got cancelled. So what you will get? You will get 1/100 minus 1/40 equal to, this is minus 1/FL you will get. True? Any doubt? No doubt, na? So moving further, so we will get 1/FL will be is equal to 1/40 minus 1/100 is equal to 100 minus 40 divided by 40 into 100 implies FL is equal to 40 into 100 divided by 100 minus 40 is 60. And how much you will get? You will get 66.67 centimeter. Okay, or it will be equal to 0.6667 meter. Now actually what I want, now I got the focal length of the lens. Now I want the power. Power will be equal to 1/f into 1/0.6667 will be equal to 1.5 diopter. Okay, any doubt? People are here now. Okay. Any doubt for this question? Hopefully no. Now, okay. Now it is going towards a mirror. Based on the following data, answer question 5 and 6. 5 centimeter tall object is placed at 25 centimeter from a concave mirror. The radius of curvature of the mirror is 40 centimeter. A 5 centimeter tall object is placed at 25 centimeter from a concave mirror. The radius of curvature is 40 centimeter. So now we have a concave mirror having radius of curvature r is equal to 40 centimeter. Then what will be the value of its focal length? F will be equal to how much? We have the equation connecting radius of curvature of the mirror. Yeah, F will be r/2 is equal to 40/2 into 20 centimeter. And we have, there's a 5 centimeter tall object which is kept at 25 centimeter from the mirror. Okay. Now we have u. U is equal to 25. V is the one which we want to know. We don't know. We know F. F is equal to 20 centimeter. So we have the same equation. 1/u plus 1/v is equal to 1/f. So 1/25 plus 1 by b is equal to 1 by 20. 1 by b is equal to 1 by 20 minus 1 by 25 equal to 25 minus 20 divided by 20 into 25, or b is equal to 20 into 25 divided by 25 minus 20, 5. 5 will be 4 is equal to 4 into 25, so 100 centimeter. Okay, so it will be like the 25 centimeter image is here, your object is here, the image will be like some 100 centimeter. That's 100 centimeter here. Okay, this is the first question. Yeah, your answer is 99 to 100, 101. They'll give the height of the image is. Now you see, you already know that one. You already did that one. Now see, we have magnification m is equal to hi by ho, and so height of the image by height of the objective, same as minus v by u is equal to minus v. V is given 100 divided by u is 25, so 100 by 25 is equal to minus 4. Minus 4, height of the image will be equal to minus 4 into height of the object. Height of the object is how much? They given 5 centimeter. So minus 4 into 5 into minus 20 centimeter. What is the meaning of minus 20? It is forming a real image at 100 centimeter, which is a big image but inverted image. That's the thing. Okay, hopefully that answer is clear. So yeah, minus 20 is the answer. Minus 20.1 to minus 19.9 is an acceptable range. Whatever you given, they will give that answer. Okay. You have candle a thin positive lens of focal length 10 centimeter and a widescreen. The shortest distance between the candle and the screen such that using the lens real images projected on the screen is. Now you see, you have a shortest, you have a lens imaging system. Now lens, we already see that the lens having a different points. The lens imaging system can be consist of different points. One is this optic center where our lens is kept. Then there is a point focus, two sides, focal length, then like 2f, then like 2f. It's like, yeah, it can go to infinity. Now we already know that real image can be formed when the object is beyond f. Correct? If object is at f, your image will be at infinity. And the object is at infinity, the image will be at f. So from you can only move points from here. If the object is here, your image will be like infinity, and so the total distance will be infinite. So if the object is at infinity, you will get an image at focus. These are the big range. and in between you have a small range where you have, when the image is at f, 2f, object is at 2f, you will also get a image distance at 2f, and the image size will be exactly same, the magnification will be 1. You can see that this is the shortest distance between your object and image, because from here to here, from this 2f, if you moved from here to 2, from 2f to f point, what will happen? Your object image distance will also change, because from 2f to f, only they are moving from a distance of f distance, but your image plane will move from 2f to infinity. So this much vast range is coming at the image plane. So the shortest distance only will come when exactly you are at 2f, and the total distance between from here to object to image will be sum of this 2f plus 2f. So the total distance will be 4f. And the question is, we have a candle thin possible 10 centimeter and 10 centimeter. Focal length is 10 centimeter. So that shortest distance between the candle and the image, and the real image, the shortest distance will be 4f, 4 into 10 centimeter, that will be 40 centimeter. And the answer is, have option like 38 to 42. You can give, they'll give proper answer, consider it as correct. Okay. Now, based on the following Oslo design, answer the question 8 to 10. You want to need to do that Oslo also? If you people have a problem for doing with Oslo,
No, sir.
you people get everything as per the details.
Yes, sir.
Okay. Anybody is having doubt regarding Oslo? Anybody having a problem to do the things with the Oslo? You can tell. Don't worry about what we will people think, or I think, or anybody think. If you have some doubt, you can directly ask. I don't have any issue. I can share the screen for this Oslo also.
Sir, please tell.
Okay. Can you do that thing, assignment for this Oslo thing? Could you do? Did you install
Sir,
Oslo?
sir, please tell.
Yeah, did you install Oslo?
Uh, sir, I don't know how to install
Okay.
it.
Okay, then I will tell that how to install. Now, okay. You people in that website, you see that Oslo, na? I'll share the screen here. Course outline, I think. Information about it. Let's see. Okay. Sorry. This is not on course. On course. Yeah, here you can see that the course will use the educational version of the optical design tool Oslo. You are seeing this one?
Yes, sir.
You go there. Okay. We'll see here. Lambda. Optics Oslo. It will come there. Go down. See. Here will be Oslo Edu free download. See.
Okay, sir.
You click there. They will ask for some of your information, like you write your name, last name, and you submit it. Then you can download the Oslo installation file. Okay, you go to downloads, programs. Yeah, then it will be
Sir,
submitted.
this access is unlimited.
Yeah, Oslo education access is unlimited. You don't need any license for this Oslo education. Only the problem is that you will get only the surface amount will be 10. That is limited. But you can design amount of surface 10 means at least you can design at least like a combination of 3 lenses. So that will be more than sufficient for not only this course, I think much more better.
Okay, sir.
Oslo premium education edition will have a lot of surfaces. You can install as much as you want. But yeah, you go like install. Okay. Then it will open like this kind of a one window. So these are the things which I just tried with these are the same assignment question which you tried. So the thing is that here you will get a different kind of parameter you have to put. So they already in the assignment they given what are the parameter you should put. You can set and see they are already given. BK7 is the glass slab parameter of glass. So that I already put here. See, this is the glass BK7 here. This is given. Beam radius I took it as some 3 centimeter. Sorry, this is not your assignment problem. This is your assignment problem. Beam radius I took it as 5 millimeter, and the angle they given as 45 degree. So I changed this one to 45 degree. You want to know from the starting? Then I can explain also.
Yes, sir.
Okay. So if you open this one, it will be like you have to take a new lens. You go file, take a new lens. Okay, and you want a number of surfaces. You want at least minimum 2 surfaces you want, and there will be an image surface. So I'll just put 3. 2 is enough. If you want, you can add. Okay. Now these are like a different surfaces. Now there's a beam is coming. So the beam radius they already given I think 5 millimeter. So I put 5 millimeter here. Then there is a field angle that also they already told in your assignment. They told design a glass slab thickness 10 centimeter, thickness of 10 centimeter. Set the beam radius of 5 millimeter and the field angle is 45 degree. So I am setting that one 45 degree. 45 degree. Okay. Now this is the object plane. Now it is coming. The radius of curvature. Now you see that it's a only glass slab, so there is no radius of curvature. So there is no radius of curvature. Oslo, they take it as a zero. The zero means actually infinite radius of curvature, or it's like a plane surface. It is like that. Okay. So now it is like this is the first medium. So the first medium from where this object plane is there, that I will take it as air only. Then I will take this is as my second medium. This is the second interface. So the second interface also radius of curvature I took it as a zero, and the thickness of the medium they told me as a 10 millimeter. This is aperture radius. You don't need to worry about that one. So this air I'll change it to BK7. What is BK7? You know, it's a particular type of glass. That is BK7. Okay, so I took it as BK7. Then now just you can put this draw off. You'll see that you can see this is a one glass slab which is moving from here, and ray. This is this blue line is actually saying about how the ray is coming. This green line is actually saying about how a axial ray is coming. This blue is the line which is giving 45-degree with respect to your axial ray. So you can see that this is a refraction is happening at this interface. Now you want an image plane, an image, since I want to see the distance of in that after the glass also, here I'll give some 10 centimeter, 10 millimeter there. Now you can see all the ray which is coming from glass slab. This air coming from air, it is entering, undergone refraction, then again it is passed through outside. This is the question they asked. Now this is the thing which you have to do. Okay. Then based on this thing, you can actually calculate all the get the questions. Now see. Now you want to see angle of refraction in the glass surface. Means air glass surface. You want to see angle of refraction. So in order to get that angle of refraction, you have to go for these things actually there in your lecture also. Can if you doubt, you just go through the lecture. So go evaluate. Then there is a single ray trace. So you put this outer format like a full surface selection all. Then print surface number is a spreadsheet for yes. This wavelength number you take the first one. There are like three types of wavelengths are there. So first one only we are taking, and that is a 0.588 micrometer. And you put it as one and put like okay. So it you are accepted. Now you put it's like okay. Now downside here you can see that this is top one. You don't worry. These are the things which I did before. The bottom place trace ray. You can see that here. You can see now. You can see my
Yes.
pointer. This is a y angle, I angle. This is like a this 45-degree is the angle of incidence. This is a R angle. That's a refracted angle. 27.786826. This is the refracted angle. So you can see in your assignment also, that's the same question. Angle of refraction in the glass surface is 27.7868. That's the thing. So directly you got the answer. Now see, what is the value of refractive index BK7 glass based on your answer? What is your angle of refractive index? In order to get the refractive index, you go here, go there, and see there is an option like R in refractive index data. And we already told that we are dealing with the first wavelength. So go here and you see RN1. There are 3 different wavelengths are there, but we are considering only the first wavelength. So this is the air. Air refractive index is 1. Next one is a BK7. So 1.5168. This is the refractive index data. So you can see that your thing also have the answer 5.5168. So that is your answer. Second answer also we got the third answer. If the glass type is changed from BK7 to BK8, what is the new angle of refraction? Theta r in degrees. So this is the thing. So here you have we selected this is BK7. So you are actually changing the glass. This is BK7 type of glass. Now we are changing to BK8. BK8 and typing there and taking and okay. This is changed. Now I want what is the angle of refraction. What is the angle of refraction you got earlier? You can say 27.7868. Okay. Now I changed it to BK8. I also go for again evaluate single ray trace. Check the full option here. Surface selection. I'll take wavelength number is 1 and my set object point that will be always there. Already selected the value here. Here. Okay. Now you go and see 45 is that one. What is the now angle of refraction? 27.72027. Earlier was a 27.78. Now it is changed to 27.7202. You can see whether the option contains the same thing. Yeah, see 27.7202 is there in the option, and the correct answer is 27.7202. Okay, don't worry about this Oslo. These are very easy. So the problem is that if you didn't install and try to work this one, then as you are going on this one, more and more problems will come based on Oslo. You can just you may have to select one of the answer without knowing. But you see that if you are knowing this answer, these are like a direct substitution. Draw the same thing in the Oslo, look at that one, fill the answer.
Okay, sir.
Yeah.
Sir, this is valid only for 3 surfaces.
Not 3 surfaces. 3 surfaces, I am saying that how many surface you want. Now you want this air, this medium, they will consider this as one surface. Then
Okay.
it will move to another surface. This is glass. This is the Oslo education. Then is again air. So this is like a 3.
Okay.
Like that way, Oslo education will support 10 surfaces.
Okay.
In that case, now you see that for glass air interface, you want one object plane, then there is another glass surface, then another image surface. So total 3 surface they used to measure this one. So
Okay, sir.
if you want a lens also, it will be like a 3 only. You want a combination of lens, there will be 4, 5. Again, you want a combination of one more lens, again it will be like a 4, 6, 7. So I am saying that if you have a Oslo education itself is enough for understanding at least the combination of like 2 or 3 lenses.
Okay,
Only
sir.
the education version you can do. So it will be like sufficient for this course anyway.
Okay, sir.
And you can do much more thing. This is the yeah. Anyway, any other doubt you can ask.
Excuse me, sir.
Yeah.
Sir, is it possible to shift the live session class on Wednesday from Monday to Wednesday?
That actually the problem is like that way. This is like a NPTEL is not supporting that one because I got that option first before the sessions are started. Like I got this option. That's why I choose this.
Okay.
option 2. But the thing is that NPTEL, it's like I cannot just change because NPTEL say that it's only possible. It's like there's a big emergency kind of thing only. Then only NPTEL is supporting that one. They're saying that is all people are intimated with the same slot, so it is difficult to change.
Okay, sir.
Any doubt? If any doubt, you can ask.
Sir, you were saying to switch it into two segments, like 1 hour.
And say which question? Yeah,
Sir,
that I will check. That I will check with this one because that in between they told because first hour session was like 1 hour per week. After that
yes.
it's changed to 2 hour per week. So they just increased that 1 hour to 2 hour. So that I think we can manage. I'm not sure. I will discuss with NPTEL team and confirm that.
Okay, sir.
Any doubt? Other?
So I have one doubt in the Oslo thing. In
Okay.
that, it was given that f by is equal to 1. Why is it equal to 1, sir?
Means I didn't get it.
The while doing the process, I think uh, setting the single rate analysis.
I think it is
There,
taking the first radius as parameter. I'm not sure. I check and I
is it
tell.
in that whole process that it in the document also is given that you have to set some parameter equal to 1 f b y.
Okay,
So
I'll check that one
yes,
again. Yeah, that I'll check.
sir, and also, sir, is it possible that you can give us hints how to solve the lab exercises for Oslo? It will be very helpful for us.
Lab exercises means what kind of hint? Means
The
this is the,
week two module lab modules and week three
okay,
lab
okay.
module.
1 minute.
The exercises are given, sir.
Okay, you
So
will
how
put.
to? Yes.
Okay, 1 minute. I just check. Okay, okay. This lab exercises you are saying.
Yes, sir. Yes, sir.
Okay, this is first one is actually your same thing what we did today.
Yes, sir. In that down in the creating the simple lens
Ah,
exercise number 2,
hmm.
there they have given that not down, so even more down.
Hmm.
A modeling a simple lens there only.
Ah, yes, yeah. What is your doubt?
There FBY even down. So there one parameter they have put that as 1. That I didn't understand.
I'm not getting.
So even down, so even after the slider wheel.
Okay, okay.
Okay, I think I missed that one. Okay, sir.
I think this is the same thing which is you are saying about the single rat race. I think.
The single ray trace
Yeah,
that
that
process.
that I'll just check. I think they have to
Okay.
keep that as one constant for.
There only say there only say change FBY to 1 and click the green check
That
to look.
yeah, that's the same
Ah,
thing which we did. I think they are
yes,
selecting
sir.
one particular thing that I have doubt. That I'll check and
Okay,
I'll tell that one.
okay, sir. And the exercise one, how to solve like
This one.
that one? Just say, yes, the practice exercises.
Could you make that lens?
Yes, I was trying to do that today only, that but I was not able to do it. So
These are like making lens is very easy. I will tell.
yes, sir, this one little bit of hint will be helpful.
This is normal exercise, na. This is not assignment problem. I can make a
No,
lens,
no, no, no. It's not an assignment.
so I can make a lens also. You have time now? No problem.
Yes, sir.
Yeah. Now just to think that okay, you can play around after sometimes. Now the thing is like that I want to make a new lens. Okay. Hmm.
Yes, sir.
I'll go file. I'll start origin. Now I'll put like 3 surfaces. Okay. This you can increase or decrease or you can add like a normal spreadsheet adding. So you don't worry about this one.
Okay, sir.
So yeah. Now it's like a completely clear. Some blank thing is came. Now enter beam radius. Beam radius also you can select anything. I just take some
Okay, sir.
3 mm radius. So the thing is that I want to see something. Field angle. If I didn't took an angle, what will be the problem? You cannot see how these lines are moving. So I will give some particular angle. This also you can change. So I'm just now I'm taking some 3.
Okay,
Okay.
sir. Yes, sir.
Now it is like a object. You are seeing the object radius. This is the radius of the object. Means you can say that is the size of the object.
Okay, sir.
Okay. Since you are defining the size of the beam, actually you don't need to define the size of the object. So that doesn't matter.
Okay, sir.
This thickness is actually the object length. If you want to design a lens with like a, if you want to make a lens, you are seeing the original image now. You want to
Yes, sir.
make a lens which is containing, and you say that an object is placed 20 centimeter from the lens, something like that way. So in that case, this thickness will be your object distance.
Okay, sir. Okay, sir.
Okay. So aperture radius, that doesn't matter because your object does not have an aperture. You are already defining that size of the object here as radius. So that you don't need to take any aperture there. Okay.
Yes.
Now that is object is over. Now you are actually coming your lens part. That will have a radius of curvature of the lens. So I am taking some radius of some 100. Okay. This is my radius of curvature of my lens. Okay. Now I am trying to draw.
Okay.
Now nothing is there. That's because of there is no interface here. Now I changed. Now I'm changing. This is air here written. So I'm changing to one glass. So BK7 is a commonly used glass. So I'm changing this one. Now you can see the first surface came there.
Yes, sir.
Okay. Now I'm saying that my object, my lens have a specific thickness. That will be a very thin lens. That will be some 2 mm thickness. Okay.
Okay, sir. Yes, sir.
Now you can see that it came with a 2 mm thickness here. But the other surface is flat.
Yes, sir.
I want a biconvex lens. So I am checking the next curvature. So there I am changing -100. See, so that is also becoming a little bit curved.
Yes, sir. Yes.
You are not seeing the whole thing because I selected my radius as 3. So if you want to
Okay.
see the full lens, just take that aperture radius. So Oslo is just taking that you only took radius as 3. So you only want to see only the 3 mm path. But if I want the total size of my lens, just increase the aperture of my lens to some 10 mm. Now see.
Okay, sir. Okay.
Now you can see that one. And this also, if you go for the 10 mm, you can see that original lens kind of thing here.
Yes, sir.
Now you go. Now you reach it till here. Now you want to your distance after this one. That is normal air only, but I am saying that I want a distance of almost like a 100 millimeter or anything. Some 50 also you can put whatever.
Okay, sir. So this is the image distance you're saying, sir?
Yeah, in the third surface distance, you can say like that way.
Okay. Okay.
Now it's like 100. It's only showing only this much. 50. The thing is that you can see here. Your lens has a effective focal length of 97. So I am putting only 50. So I just put like 100. Oh, okay. So it is only showing that one thickness. So I will put a solve here. Solve axial ray height 0. Okay. Actually now it is solved here. But here I will say that I want to see the image. So surface control you put. These all things are there in that
Yes, sir. Yes. Yes.
draw. Yes. Now you can see that at almost like 100 centimeter, the lens is
Yes.
focusing, and you got this image also here. And if you want your object here, then put this thing also draw. General draw. This is like a, why this is like this way, your object is something like at infinity. That's
Okay.
why
Okay.
it is showing
Okay.
that
Uh-huh.
only. So just change
Okay.
it to object distance. If I'm putting some object thickness now, this I'm just changing to some 200. You can see that this is like a 200 centimeter image forming a object, forming a image at some 100 centimeter.
Okay.
And
Okay.
now you can see from here, you can exactly see this is the object distance 200. This is
Yes,
the
sir.
187.40497 is the image distance. Directly you can see from here because you put a solve here.
So first thing you do is solve, and then only we get the image distance, sir.
No, the thing is that, yeah, if you put a solve, and I'm saying that at a solve, my axial ray is coming to 0. So when axial ray is coming to 0 height, that's the point where your image is formed. So that's why it will take the data as 187.40 that time. So it is
Okay. Okay.
from here you can read. Actually, otherwise you can directly read from your other parameters also from here we can take. But if you put a solve here from this spreadsheet itself, you can read that value. And here also you can see 97.0797 is the effective focal length of the lens. So like that way, you can play around this one. These are like easier.
Yes, sir. Thank you. Thank you so much, sir.
Okay. Any doubt? Hopefully, session is good. And yeah, so can
I
I
think
stop the
no.
presentation?
Yes, sir. No doubts for now. Now, sir. Thank you, sir.
Okay, okay, okay. Thank you. We can see
Thank you.
next week.
Yes.